My project for the neural network course, and the title is about facial key point detection from Kaggle competition. And the objective of this task is to predict the key points position on the face images. And this is the application of this model that you can use later. And the evaluation method for this method is using RMSE, which is this formula dividing, subtracting the predicted value with the label value and the squaring of them and mean of all of them, and the last taking the root square of them. So the purpose is to punish the larger errors. How my data from the competition, it contains one training CSV file. It contains 7,000 images. Each row contains the X and Y coordinates of 15 key points. So in total, 30 points for X and Y's. So because every key point has one X and Y level, one Y's. And also the last order of is the pixel values for the image. This is how gray images, not color images, and the test file contains 1,783 test images, and each row contains label image and also the pixel values for that. And so let's jump into my code. This menu bothers me. Okay, so I start with importing my all necessary thing and downloading the data and feeding it to the model like as train and test. So here we can see that train shape contains 7,049 images, and each of them is 31. So 30 is for 15 key points that each one has one X and Y W, 30. And the last one is the image itself that contains a long flattened layer that contains the value of the pixel value for the images. And the test shape contains 1,783 images, one label and one the image itself. So let's check for the missing value, because as I told you, there are some missing values in the data. So they intentionally left them blank. So for example, we can see that for the left corner are X and Y W's. There are lots of missing values. But if we want to just ignore and delete every image that has some missing value, I wouldn't have enough data to train on them. So the idea that I came up with is just to fill the data from the previous values in the in the CSV file. That's the result. Actually, maybe if I delete this data, if I want to work with small data, I had to apply very complex, like data argumentation. Unfortunately, I didn't have time, so I just came up with the most convenient way at the beginning, just to fill the data. This is how my trained data looks like. One more thing I just want to add. For example, some of the images, they just miss the value for one key points. So there is still 14 key points there's available. So if we just delete them, so we are losing some information. That's why I just came up with this filling idea. So this is how my trained data looks like. This is the labels for images 0, 1, 2, 3. So each image has these coordinates. For example, for the center left eye, this is the X and Y value, and for right value, and also the other key points here that we have, like nose and mouth coordinates, and the total. And the last, we have this image. This is the value for the pixel of the image that is, distinguished by the space. And this is my test data. This is the label, and this is also the image for the test data that I have. So yeah, I just checking the missing values. So we see that there are 28 parameters that has some missing values, the key points. Just 3 of them doesn't have any empty space. So I just came up with this method that I just found it, fill NA method, forward fill. It's just using the previous data just to fill the data, like the exact coordinates. Same place through this just means that it's saving the current file, so it's not creating new file just at the previous data. So I defined this process image function here. So it's getting the data that I'm going to put it. So just to make a flattened layer as an image. So here I just defined the empty list of images. So for every index sample in the data iteration, it's going to iterate from all the values. So whenever the label is image and they are split by space value, so I'm getting the data type as the integer value, just the image, and then I'm going to reshape it by 96 and 96 because the image size is 96. And then just appending that image to the image list here. Then at the last, I'm just dividing by 255 just to get the value between 0 and 1. That's how I want to work with my data. Actually, the purpose is I could have defined dense, huge dense layer and just fit the flattened layer to it. Eventually, it will learn something, but it's better to process the images. This is more rational to work with the images. And here I defined this key points data, so it's going to get the key points coordinates and just get that from the data. So here I'm just dropping the image column because I don't need that. I just need the values that first it's empty. So it's again I'm just iterating from my CSV file and just getting appending the I'm just appending the key points to these key point features, and then just returning the key points at the last. Here I defined the label in my test data, the image label as my test. So, and this is how it looks like the values of the pixels in my test image data. So I'm going to process my train data here using these two function that I defined, process image and key points on my train data. So this is for X train and Y train. So here I'm just going, let's see one of the inputs data. That image is going to be like this. And here I defined another function, image with key points. So it's just going to add the key points on that image. And it's going to show it with the red lights that starts on the image. So it's just appending. For example, here I have from 1 to 31, and it's just moving 2 by 2 because for every key points I have one X and Y values. So I have to move 2 by 2. From 1, and so this is for appending X value, and this is appending for Y value on the image coordinates. So here, using this image with key points. So for example, I just plotted the number 200. So here we can see that image, and this is the key points on the face: 3 for every eyes, 2 for each eyebrow, and 1 for nose, and 4 for mouses. So you can see that it's labeled very well. So because this is my train data, and this is some other training inputs. Here you can see that. So let's come to my model. I just imported everything that I needed from TensorFlow. My image size 96. This is my input. It's going to how it looks like. This is one channel and image size 96. So I just defined 4 layers of convolutional networks. I used more filters at the beginning and fewer filters at the later because I want to capture the patterns at the beginning. So this is not very huge model, but my subscription to Google Colab just finished. I don't know. I was training on that a few days ago, but it's just finished at the beginning of the month. So I couldn't use Google Colab, so I had to use my own computer. So I came with this model. So in total, we can. After convolutional neural network, I just flattened my data, and then I used these dense networks, dense layers here, because I have to feed it. And the last layer contains 30 neurons because of my model. I have 15 key points, and each of them have one X and one Y value. So in total, I have 13 outputs that I'm going to predict, and my model should learn that. So this is a summary of my model. So it contains almost 600,000 parameters. And some of them are non-trainable because I have this normal Bayes normalization here. So there are some statistical parameters like standard deviation and other things. So I defined it RMSE because my model is going to be evaluated on the RMSE value. So I used ADAM optimizer, which is adaptive momentum optimizer. So it's going to adjust the learning rate by the momentum that of the last value. The last value is MAE, and also metrics is RMSE that I just defined it here. I use early stopping, and I'm going to validation monitoring the validation loss or validation RMSE both are almost the same. The patient's 200, and I'm using 100 epoch, and I'm going to restore the best values. I use 20% of my data as validation data. So here we can see that after 43 epoch, I just converged. So we can see that the epoch 23 had the best validation RMSE here and the minimum validation loss. So you can see that, the best validation RMSE that I got is 199. So it's almost 2. So we can see that every predicted value for the validation data, it's 2 pixels up in X value, X direction, and also 2 pixels away on average, I mean, from Y direction. So if you want to also mathematically convert it, it would be 2 root square 2. So it's almost 3.5 or something like that. That is divided from the labeled value on my prediction data. So let's also use this model on the test data, how it performs and how it looks like. So I just I use this process image on my test data. I use the function that I already defined to process image and I'll say on the test data. I'm going to convert the flattened arrays of test image to the image, and then I'm going to predict the use my model to predict the key points on the X test data. Here I have to define this function image with predicted key points, and here it uses the predicted value to append the key points, the X and Y values on the image new image. So let's see some images here. Image with predicted key points for let's say the image 500th image. So you can see that for the eyes, it did a not very good job, but it did a good job. For example, the center, it contains, I'll say it predicted very good. Actually, for eyebrows, it also did very good job. But for mouth, it's a bit away that you can see that. For the nose, also it did a good job actually. Let's see another image, image label 100. So you can see that here for this one is also a bit off here for the eyebrow, but for the eye, it's not bad. It's good. For the mouth, maybe the mustache here making some problems for our model. It did a very good job on mouth. For this picture here, we can see that for the eye and eyebrow is also again good, but for mouth there are some, I'll say, errors that we can see. Maybe because of the missing value that we already had in our data file, and just we use just to fill that missing value with the previous value using forward fill method. Maybe that was the reason that this problem happens, because there are lots of data was missing for mouth, so it cannot learn from this trained data. Let's see another image here. For this one is also for eyes. It's not very clear picture, but still we can say it is acceptable. For the mouse is also not very good. Again, for this picture, because this is a painting almost, we can see that it did a very good job again for the mouse and for the nose also, and also it has some, I would say, angle that is not looking directly. Yeah, so it's not similar to other input data. But this model is also very vague and it's not very clear, so it didn't do a good job on this one too. For this picture, let's say, yeah, it's again vague and it did it very good, but still somehow this basic model is acceptable. I just tried to use a bigger model. I just added more layers to convolution layer, and I just used the huger, more filters actually, just to see how my model can look like. So it contains more parameters, but every FX takes almost 1 hour to complete. But I cannot run it with my own computer if I want to go, let's say, for 50 FX at least, like previous. And I think even using larger data cannot help me a lot because it's already learned, I think, with the convolution layer. I just also came up with another idea just to using pre-trained model like VGG16, but that's also trained for color image. I could have, concatenate my image 3 times and just use that as 3 channels same, but it won't be very nice. I don't like this idea actually. I could have do that, and I could have used a VGG16, but I'm not sure if I could have get a better result with that one. Another idea that I came up with is as a data augmentation, just to zoom in the images. And the problem is it would be very complicated if we want to zoom the X and Y coordinates. It would be a bit mathematical coordination, but I couldn't have time sorry for that, but that would be very interesting if I could have done that data augmentation.